Hello everyone. In previous lectures, we have learned about Pandas basic. In this lecture, we will learn some advanced data filtration and manipulation in Pandas using sample sales data, which gives us some more realistic scenarios. This is our sample data, sample dash superstore. And so let's start with this importing with the Pandas. So first we have started our Jupyter notebook and then we start importing with the pandas. Next, we will create data frame of sample data. Our sales data is located at E drive, so we will provide the full path to the Excel file. As you know that in the Python, when we use the slash, so we have to use the rather than single slash, we have to use the double slash because single slash will give the other meanings to the Python. I just copied the name and provide the sheet reference, shift enter. So there is no error here. So it's mean the data frame has been created. Now the data frame has been successfully created. To see the sum of the top rows of our data frame, we will use the command df dot head. So this will give us the some top rows of our data frame. Here you can see we have very detailed sample sales data with 21 columns, including product name, including product category, subcategory, product name, and sales in dollar and profit as well. This is a very decent and realistic scenario data and comprehensively give us the realistic picture. Let's start with some analysis on this data. The first thing we need to find out the shape of our data frame. Shape means how many columns and rows of this data frame has. So for this we use df.shape. So this data frame has the 9994 rows and 21 columns. Now we must aware about the data types of each column as well. So for this we will type df.dtypes. We have now data types of each column. Here we can see the four different data types such as INT64. INT64 is integer or number without decimal. Then we have the object data type. Object is basically a string or text. Then we have date times 64. Date times 64 is basically date and time. And then we have float 64, which is float or the decimal value. After finding out data types, we have to ensure the consistency of our data. Is there any missing data or cell have any null value in our data types or data frame or not? For this, we have to type df.info. This shows our data has total the range index or the total number of rows of our data is 9994 and the columns are 21 and there is no missing value, otherwise results might not be accurate. So for example, we see here that total number of rows are 9994, and if we see the all the columns here, all the columns also has each column has every column has the 9994 rows in it, means every columns every cell has the data in it, so there is no null value at all in it. But for the some different results, and just for to give you an example, I have created a sample copy. I have created a copy of my sample data deliberately and deleted some values from the column sales and the product name and save it as a sample dash sale superstore dash copy xlx. Let me import this file into df2 and we'll see the df2.info for the result. So let me just copy this thing here to avoid typing, and I name it df2 and file name is shift enter, and now I will type df2.info, shift enter. So you see now here you can see the range index is 9994, means the total number of rows. But if you see the column number 16, product name, has the values 9985. Similarly, if we see the column name, column 17, sales, it has the values 9989. So, so this means that these two columns have the some missing values as well. So either we have to fix this by removing those rows, from data or by adding the missing values. We can also use the df2 dot is null dot values dot any true. So this also give us the boolean result if there is any null value in our data set or not. But if I write same thing for this df dot is null dot values dot any for my actual data set which does not have any missing value, so it will give the boolean result false, means if this data set which is df data set does not have any missing value. There are some other commands as well which gives you information about your data set, such as df.index. This will also give you the total number of rows, and df.columns. This gives you the name of the columns of your data set. Similarly, df.count. It also gives you the summarized picture of your data and the total number of uh, values. Let's continue with our actual data without any missing values, which is df, and we'll analyze the data and we'll find out that how can we summarize the data in different formats. For example, to have a general summarization, we can use df.describe. Df.describe will give you a general summary of your data. What it does, it just do the summary on your numerical data such as profit, discounts, and it just give you the total number of counts, mean, standard deviation, minimum, percentages, and maximum. But this is just a default general summary. We can do the uh, summarize the data, or we can find out the different things our own as well, such as to find out the total value of sales, we'll use df df sales dot sum. So this will give us the total value of the sales. All it will sum out the all the values in the sales column and give you the total value. Similarly, if we would like to find the maximum number in any numeric column, for example, to find out the maximum profit, we will use the df profit dot max dot max. And similarly, we can use the min for the minimum. The other things which we can also use like mean, median. For mean, you can use the dot mean, or for the median, we can use the dot median, such as. And similarly for the median, dot median. We can also group by the results as well. For example, if we need to find out the total sales and profit of each category, then we'll use the uh, group by clause. So for this, we'll use the df dot group by. We would like to group by category, and then we would like to sum it, and we would like to sort the values um, on the basis of quantity. Let's do it this first. So this can be done like this without sorting anything. But if you'd like to sort the values as well, then we can do it as well, like by sort. Let's go values. And we can also pass the parameter by ascending, descending as well, is equal to false. So this will be in descending order. So you see now that there we can find out the total profit, discount, quantity, and sales of each category. So there are the three categories: furniture, office supply, and technology. And we just did the sum of all these three things in this group by these categories. And we can do it by the region, by the country, or the anything else as well. We can group by with the multiple columns as well. For example, if you would like to find out the total s- values of the profits, some discount like this, but region wise and category wise, then in each region which category has what sum. So we can do it by df dot, sorry, not group by region, comma, category dot sum. So here you can see that now the data has been grouped by with the primarily on the region, central, east, south, west, and then the second group by is based on the category. So each category is repeating in the each region, and now we can find out the sum of the numerical values in the each region and the each category wise. One thing you might notice that when you are using the sum in general, so it basically some it basically total the all the integer or float values, including the postal codes and the row IDs as well, because both of these are the integer values. So it just treated it as whatever the numerical, it cannot differentiate it whether it does make any sense or not. So definitely these two columns summarization doesn't make any sense to us. But yes, these columns like the sales, quantity, discounts, and the profit does make sense to us. Sometime we also would like to create a new column as well based on the any existing other columns. For example, if you would like to create a new column which is total price or the total sales by multiplying the sales multiplied by quantity. So this will give us the total price of that particular row or the sales. So we'll do this by uh, df total price. This will be a new column is equal to df sales multiply by df quantity, shift enter, and I have to display it as well, df. So let's do it by df dot add. So it will just give us the initial 5 rows, and in the end we can see the new column which we have added. The total price has been added, which is the basically product of the sales into quantity. Let's suppose we do like to find out region wise number of products, means that in which region how many products we have sold out. So we can find out that thing, this data as well, by df dot group by region, and then product name, and then an unique. So if without unique I just go with it, so it will give me the repeated products names. For example, if I have sold out the Xerox printer multiple times in central regions, 4 times, so it will consider those, add up those values into this thing. But if I would like to see that how many unique products I have sold out in the central, east, south, west, each region, so this will give me a unique that uniquely, Center has sold out the 1295 products, and East has sold out the unique 1415 products, and similarly other regions as well. In the pandas, we can plot the our data into the graph as well. And for this, we just use this thing. For example, if I just copy this thing here and just by typing plot, this will give you a default line plot or line graph of your product name in each region. You can also create the different type of charts. For example, if you would like to create a bar chart instead of line chart, you just have to pass a parameter. So type in kind is equal to bar, and this will give you a bar chart. Similarly, if I would like to have a pie chart, so I give pie, and this will give me a pie chart here. Make sure you have installed the matplotlib library in the Python as well to use these charts as well. For example, if I would like to have a profit by each category, so I will do the df dot group by category profit dot sum. So this will give me a profit uh, of each category. And if I would like to plot it on the bar chart, then I'll do the plot kind is equal to bar. bar. So here I can plot this thing as a this in the chart as well, or in different chart as well. So this is how we can use the pandas for the some data analysis, and today we did it for some real data. If you have any question, please do let me know. I'll answer your queries. Thank you very much. Have a nice day. Goodbye.